Hey, what's up? Today we are going to talk about a data type in Swift that is often overlooked, even though it has some interesting use cases. And this data type is tuples. So let's see what a tuple is in Swift. So I'm going to create a variable called tuple, and inside I'm going to actually store a tuple. So to begin, the most simple kind of tuple is the empty tuple, and it's actually equivalent to void in Swift. Of course, a tuple has a real interest when you start to put values in it. So first I'm going to put a string in this tuple, so it will be hello world. And now if we take a look at the type of our tuple, we can see that it is a tuple that holds a string. But what's super nice with a tuple is that it can store several values and they can be of different type. So for instance, the second value stored in this tuple can be an int, and then I can store a double. And if I take a look at the type of the tuple, we can see that now indeed it is a tuple of string, int, and then double. So now that we have this tuple, how do we use it? How do we access the fields? Well, by default, when the tuple is declared like this, so just the values, well, we access the field using a positional notation. So 0 is the first element, so hello world. So if I print it, it's going to print hello world. And then, as you can imagine, next element is accessed by using the index 1. So this one is going to print 42. And if I use 2, I'm going to get the double free. Okay, so this is the basic way to use a tuple. You store some data in it, and then you access the data using what we could call anonymous fields. But what is really nice is that we can also name some of the values. So for instance, I'm going to name the first value string, and now you can see that of course we can still access the value using the positional notation, but we can also access it using the name, so which is string in this case. And what's super nice is that this is a compile time safe notation, meaning that if by mistake I make an error, I make a typo, the compiler is going to catch the typo. So it's very similar to what you would find in a struct, for instance. Also, in a tuple, we can update the values. So for instance, I can set a new number in the field that is an int, so in the second field of the tuple, and it only works as long as the tuple is mutable. So here it's a var, so it works, but if I change it and make it a let, you can see that it no longer works, and it shows that tuples, they are just like structs, meaning that they are value types. So what can we take from this small example? Well, basically, we can see that a tuple, we can kind of see it as a simpler version of a struct, meaning that it is kind of like a struct, except that all the fields are public and not all the fields need to have a name. Some of the fields, they can have no name, and in this way, we will access them using their position in the tuple. And just like a tuple, we can do some very interesting things when the content of the tuple are equatable or comparable. So I'm going to declare a second tuple. So it's another tuple. You can see that the type is the same because it's a tuple of string, then int, then double, but the values are different. And now if I try to compare both tuples, so of course I expect this to return false, but what's nice is that the comparison actually builds and I can run it. And the reason is that if all of the types stored in a tuple are equatable, then the tuple themselves are also equatable. And the way the comparison is made is that each field are compared and then the AND is done between all of the booleans. So for two tuples to be equal, all of their fields must be respectively equal. And the same principle also goes for comparable, but with a little difference, is that as you can see, I have pasted some more code, and so I am comparing this tuple with this one. And what would you expect the answer to be? Personally, at first, I expect it to be false, because here the first element is indeed bigger, but then the second one is not bigger. However, if we run this code, we will have true return. And the reason is that the comparison is made in a different way than for the equality, meaning that it's not made member-wise. And what's happening is that our code is going to compare the first element of each tuple. If the two elements are different, they will be compared using the operator, and the return of this comparison will be returned. And it's only if the first element are equal, which is not the case here, that the comparison will move on to the second element, etc. So it might seem a bit weird because it's not necessarily the way that we do comparison in general, but it is very useful in a specific use case. It's, for instance, when we want to compare version of an OS, because here, let's say that this tuple represents iOS version 14.2 and this one represents iOS version 13.4, and we want to say which is the most recent version. Well, of course, iOS 14.4 13.2 is more recent than 13.4. So this is the use case that tuple comparison implements, and even though it might not be what you want in most cases, there are some times where you actually want to implement this kind of comparison, and to do it by hand it can be a bit tedious, and you can just use a tuple and it will do it for you for free. And finally, something that is super useful when working with tuples is that we can also give a name to a tuple using a type alias. So here you see I have declared a type alias called myData, and it is a type alias of a tuple with a string, an int, and a double. You can see that we can also put the name of the field in the type alias, and now I could take the value here, for instance, I copy it, I paste it. So I'm going to call it again another tuple, hello world again, and I can type it with my data. And now I can use this tuple type with a name. I don't have to use this signature, which is a bit long, and we wouldn't want to have to write it by hand every time. So I said that tuples, we can see them as a lighter version of a struct, but there is still something that a struct can do and that a tuple cannot do. And the main limitation is that you cannot make an extension on a tuple type. So for instance, let's try to make an extension on my data. And as you see, we have a compiler error which says that non-nominal type myData cannot be extended. And that is because a tuple cannot be extended in Swift. So it means that, for instance, we cannot make a tuple conform to codable. So even though a tuple, you can see it kind of like a lighter version of a struct, it cannot do everything that a struct does. So you might be wondering, when is it actually useful to use a tuple instead of a struct? And there are several possibilities. The first one is whenever you are prototyping some code. When you are prototyping, you want to go fast, and maybe you want to introduce a new type, but you don't want to spend the time to declare a struct. Then in this case, you can use a tuple. Why not give it a name with a type alias? This way, once you are done with the prototyping, meaning that your code is ready to be polished, well, you can come back on the tuple and change it to an actual struct if it makes sense. Another instance where a tuple can be really useful is when you have a function that needs to return several elements. For instance, maybe a function needs to return the result of a computation and maybe a boolean to say whether or not the computation actually was successful. In this kind of cases, returning a tuple can be a lighter way to return two values instead of one. And finally, maybe a third place where tuples can be useful is whenever you are about to declare a nested type, for instance, a struct inside of a struct. Most of the time, these types, they are going to be very simple. It's just going to be a type with some properties and nothing else. And in these instances, most of the time, a tuple could do the same job. Of course, the only limitation is that, for instance, a tuple cannot be codable, so you cannot encode it or decode it. And that's all for this video, where I wanted to give you an overview of what tuples are and how they work in Swift. Now, I'm sure that there are many use cases that I haven't actually covered, so if you are using tuples in a way that I haven't described in this video, well, please let me know in the comment. I will be super interested to know about it, and I'm sure the other viewers will be also. Thank you for watching, and see you next time.